Welcome back. Last lesson, we met tokens, the atoms of AI. Today, we look at the room those atoms live in, the context window. By the end of this lesson, you will understand why long chats get expensive, why an AI eventually forgets the start of a conversation, and why bigger context windows are a big deal. We will meet the idea of attention, how the model decides what matters, and learn a simple habit that keeps your context window lean. Quick recap. AI predicts the next token, one piece at a time. Tokens are roughly 4 characters of English each. Everything you type becomes tokens. That is how the model reads your text. Now, where do those tokens go? They go into the context window. So what is the context window? It is a fixed size slot, measured in tokens, that holds everything the model is currently looking at. Every model has a maximum. Common sizes these days are 8,000, 32,000, 128,000, and sometimes up to 1,000,000 tokens. Bigger window costs more per turn, because the model has to do more math. What actually lives in the context window? More than you might think. Your current prompt, of course. But also, the model's previous answers, your earlier prompts in the same chat, and usually some hidden system instructions from the provider that you never see. All of that, every token of it, sits in the window together. The model sees all of it at once when deciding what to write next. Everything in your chat, every prompt, every answer, sits in the window together. The model sees all of it. How does the model actually use the window? It looks at everything in it at once, and weighs which parts matter most for predicting the next token. This weighing process is called attention. Every token can influence every other token, in any direction. Some tokens matter more for the next prediction, some matter less. The model learns these weights during training. Attention is where intelligence really lives, not in some magic thinking process, but in the math of weighing relevance. Here is the catch. The window has a hard cap. When new tokens come in, when you send a new message, the oldest tokens in the window get quietly dropped. The model literally forgets the start of the conversation. And here is the tricky part, this is invisible. There is no warning. There is no error. The model just stops remembering what you said at the beginning. It will even keep talking as if it remembers, which is how confident wrong answers creep in. How big are real windows in 2026? Small or cheap models tend to offer 8,000 to 32,000 tokens. Mid-tier models usually offer around 128,000 tokens, roughly 300 pages of text. The top-tier models go up to 1,000,000 tokens, a whole long book. Bigger is newer, costlier, and sometimes slower. For most everyday work, even the small end is plenty. 1,000,000 tokens is a whole book. 8,000 is a few pages. Most chats fit comfortably in the small end. Here is something most people do not realize. Every turn reprocesses the whole window. So if your window has grown to 10,000 tokens, every new message costs 10,000 tokens of input. Double the context, and you roughly double the cost. A long chat can easily cost 10 times what a short chat costs. Even plans that advertise unlimited use often have soft caps, where the provider starts slowing you down or refusing long contexts. Here is a piece of jargon you might see, the KV cache. It is a speed trick. When the model processes your tokens, it does heavy math. To avoid redoing that math for tokens it has already seen, it stores intermediate results in a cache. This makes generation faster. It does not make the model smarter, the output is identical with or without the cache. It is a performance optimization. Nothing more. Do not let anyone tell you the cache gives the model memory or intelligence. It does not. Here is something newer. Some models, called reasoning models, write out their thinking before answering. They reason step by step, and the reasoning lives in the context window. More reasoning means more tokens used, which is why paid reasoning models cost more. You are paying for thinking room. Whether that thinking is worth it depends on the task. Easy questions do not need it, hard questions often do. Reasoning models think out loud, and that thinking lives in the window, just like everything else. Here is something that surprises people. AI has no memory between sessions. When you close a chat, that window is gone. Your next chat starts from zero, the model has no idea who you are or what you talked about before. Providers fake memory by saving past conversations and quietly resending them in your new chat. But the model itself remembers nothing. Inference is stateless. This is important, and we will come back to it when we talk about agents and persistent memory. What can you do to manage the context window wisely? Start a fresh session when the topic changes, that resets the window. Do not paste huge documents into the chat unless you really need to. When you are using a tool like OpenCode, reference files with the @ symbol instead of pasting their contents, the model loads only what it needs. And for long chats, consider summarizing what came before, then starting a new session with that summary. If you remember one idea from this lesson, remember this. The context window is the model's whole world. If something is not in the window, it does not exist for the model. A bigger window costs more, but lets the model see more at once. Window overflows silently, the model just forgets. And memory between sessions is faked by the provider, not real in the model itself. The context window is the model's whole world. Outside the window, nothing exists. Quick recap. The context window is a fixed size slot, measured in tokens. It holds everything the model currently sees: your prompt, previous answers, hidden system instructions. Attention weighs which tokens matter most for the next prediction. When the window is full, the oldest tokens silently drop off, and the model just forgets. Here is a small exercise. Open any chatbot. Have a long, wandering conversation, at least 30 turns, on purpose. Talk about a few different topics. Then go back and ask the model about something specific from your very first turn. See whether it still remembers, or whether it confidently makes something up. That moment, when it forgets and pretends it remembers, that is the context window overflowing. Terms you now know. Context window, the fixed size slot, measured in tokens, that holds everything the model currently sees. Attention, how the model weighs which tokens matter most for the next prediction. KV cache, a speed trick, not intelligence. Stateless, the model has no memory between sessions. Reasoning, thinking out loud, written into the context window. 5 more terms. You are building a real vocabulary. Coming up next, why AI is so confidently wrong. We have established that AI predicts, does not know. Predictions can be wrong. And when an AI is wrong, it is wrong with full confidence, it has no internal sense of doubt. That is called a hallucination. In the next lesson, we look at what hallucinations really are, why they happen, and why they are the single biggest weakness of every AI today. After hallucinations, only one topic left in this phase: grounding. Grounding is the cure for hallucinations. Once you understand both, you understand more about how to use AI well than most working professionals. Context is the model's whole world. Master this idea, and the rest gets easier. Thanks for spending this time with me. Next, we look at why AI is so confidently wrong: hallucinations.